The following question reads that a cell X has an EMF of 2 volts and an internal resistance of 2 ohms. Cell Y has an EMF of 1.6 volts and an internal resistance of 1.2 ohms. These two cells are connected to a resistor of resistance zero point 0.8 ohms as shown. So these two cells are connected and they have these internal resistance, and he's asking for what is the current in cell X. So what is the current that's passing through cell X? Now, the first thing we're going to figure out is that the total EMF of the circuit is 2 minus 1.6, which is 0.4 volts. Because there's a cell over here and there's another cell in series. Remember, in series, the voltages are going to add up, and the resistances in series are also going to get added up. So the total EMF in the circuit is, there's one battery of 2 volts, there's another battery of 1.6 volts, but they are facing each other. They're pointing in the opposite direction, which means that the net EMF is going to get cancelled out. This 2 voltages, the positive side is on this side. This 1.6 volt battery, the positive side is also facing the wrong side. They're both facing each other, which means that the voltages, the EMFs are going to get subtracted. They're going to get cancelled out. So 2 volts, subtract that with minus 1.6 volts because that's in series. So the net EMF in the circuit is going to be 0.4 volts, which is going to be distributed on the other resistors. The voltages, the EMF gets distributed in series on all the resistors. So the total resistance of the circuit is 2 plus 1.2 plus 0.2 ohms. Internal resistance for this battery, 1.2 ohms and 0.8 ohms, they're all in series. So the total resistance is going to get added up, and it would come out to be 2 plus 1.2. So that would give you a total of 4 ohms. Now, the last thing is that since it's a series circuit, that indicates that the current is going to be the same across each component. In series, the current is constant, it's constant, and so we can simply apply V is equal to IR. The total EMF is 0.4 volts, so that's your V. Let me put a V over there. V is equal to I is the thing that we need to find out. So V is equal to IR, and R over here is 4 ohms, and if I make I the subject of the equation, it's going to be 0.4 divided by 4, which is going to give me 0.1 amperes. So this 0.1 amperes is going to be flowing through each component of the circuit, and that is going to be your answer. It's going to be the same current that would flow through cell X, so A would be your correct option for this question.